Lesson 32 is our first delve into integrals, also known as antiderivatives. So we have spent a lot of time up until this point working with derivatives, correct? And I do kind of wonder if this is a good or a bad day to introduce antiderivatives, but okay, we've worked with derivatives. We've learned derivative rules of like a power, right? So brief review. Derivative of x to the fifth. 5x to the fourth. I know, this is why I'm just throwing a couple of things out there. The derivative of x to the fifth, you bring the 5 out front, subtract 1 from the power, 5x to the fourth, yes. Derivative of sine x is cosine x. Derivative of cosine x is negative sine x. Derivative of e to the x is itself, e to the x. Derivative of natural log of x, 1 over x. I don't know, we may have others that we know at this point, but those are the ones that are coming off the top of my head. Okay? Now, what we're learning is the antiderivative. So, to kind of lead you in here, let's look at parts A, B, C. Find the derivative of each of the following. So, d dx of x squared is saying find the derivative of x squared in relation to x. So what is the derivative of x squared? 2x. Okay? Part B. Find the derivative of x squared plus 42. (2x) because the derivative of 42 would be 0. Okay? Find the derivative of x squared minus 165. 2x. Okay? Noticing a trend there. Yeah, always 2x, right? No, that's not the trend I'm looking for there. Okay? So those are all taking the derivatives. Antiderivative is going backwards. Okay? So antiderivative is going backwards. So this says let f of x equal 2x. Find a function, capital F, that is an antiderivative of f. So antiderivative means you're reversing your process. Instead of moving your power out front and subtracting 1 from your power, you need to reverse that. Right, so we're adding 1 to the x power. To the x power? Not what I meant to say there. We're adding 1 to the exponent. So if it's x to the first, when you add 1 to the exponent, it's going to be x to the second. And then divide by that new power out front. Well, that 2 divided by that new power of 2 basically cancels each other out and you have 1. Now, this is an antiderivative, yes, because the derivative of x squared was 2x. Is this the only answer we could give here? We could give infinite answers technically because there could be any type of what here? Constant. Any type of addition or subtraction of a constant. And so when we give an antiderivative, we tag on a plus c. Remember that word search some of you did? And actually, yeah, I think only one person's turned it in now that I think of it. But remember there was a plus c in there? Yep. Here you go. Plus c. Now you understand.
Actually, I think I asked you, I was like, what is plus c?
Yeah, and I said it would come up. Okay, so first of all, this plus c stands for a constant where c is some number. So I'm going to write that in here so we have it. Constant where c is some number. It really could be any number. Okay, it could be a fraction, it could be a decimal, it could be positive, it could be negative. Okay? Now, the point, and I forgot to write it up above, is that as you do antiderivatives, realize there's no unique antiderivatives. Because just when we say find the antiderivative of 2x, we don't know what constant could have been there. Okay? And so for that reason, there is no unique antiderivatives ever. Because it could represent a variety of numbers. So no unique antiderivatives. I would make yourself a note there. So, beware in homework, when they ask you for the antiderivative, you're doing the opposite of the derivative. Also, beware if they give you, or just kind of take notice, I guess, you know, the original function is defined as just normal f of x, lowercase f of x. When they ask for an antiderivative, it will be usually use a capital f of x. So, capital F of x and lowercase f of x are not the same. Okay? Okay, so that's antiderivatives. An integral is doing the same thing. Okay, so whether we talk about find the antiderivative or find the integral, it's the same thing. The difference is eventually we'll talk about definite integrals, so where you can find a value. For today, every time we talk about an antiderivative or integral, we'll be tagging on at the end plus c. Okay? And beware, that will cost a point on test. Because it's a necessity, but so easy to forget. Okay, so indefinite integration is the process of finding the set of all antiderivatives of a given function. When we say find the set of all antiderivatives, that's tagging on the plus c. We call this set the indefinite integral. The following notation is integral notation. So, that little curly Q thing, that's the integral. Okay? And when you see that little curly Q thing called the integral, that is saying find the antiderivative. Okay? So integral notation, this would be saying find the integral or antiderivative of 2x dx. Okay? When you reverse this and you find that integral, the integral and the dx will drop off. And you'll notice, so the key you're looking at it basically here is what is the antiderivative of 2x. The antiderivative of 2x is x squared plus c. This is your integral notation. Okay? Important that when you're writing your integral notation, you get in the habit of tacking on the dx. Or if it's in terms of y, you're tacking on a dy. If it's, whatever variable it's in terms of. Okay? So let's look at example 32.2 here. Find the integral of cosine x dx. I don't know. Is it? She suggested sine x plus c. So now I've heard sine x and I've heard negative sine x.
I said negative sine x.
Okay. Here's my check. If we say the answer is sine x, what is the derivative of sine x? This is my check. What is the derivative of sine x? Cosine x. So, what is the antiderivative of cosine x? Sine x. Don't doubt yourself. You were right the first time. Okay. And she did have the plus c in right at the beginning, so that's good. But that's what I always stop and do, because I'll be honest, even however many years into teaching calculus I am, I still have to stop and think, okay, do I need a positive or a negative here? And so I always go back to, I am very confident in my derivatives. I know the derivative of sine is cosine, so I can work backwards. I know the derivative of cosine is negative sine, so I can work backwards. But I still have to go back to those to this day. So, and you can always work and check yourself here. Okay, thoughts on example 3? The integral of negative sine t dt. It's some form of what? Cosine? Some form of cosine t, right? The key is it positive or negative? Okay, so here's the thought. Take one and try it, right? If we just start with basic cosine, what is the derivative of cosine? Negative sine t. So what's that say here? If the derivative of cosine is negative sine t, what's the antiderivative of negative sine t? Cosine t. I say, did I hear it that time? Okay. What about the integral of e to the x dx? Agree? Disagree with her? Agree? Because if the derivative of e to the x is e to the x, then the integral of e to the x is e to the x. Just don't forget your plus c. And lastly, example 5. Let dy dx equal cosine x. Find y. What are they asking me to find? What is dy dx? The derivative. So what is y? The antiderivative. Okay, the original. Or in other words, they're asking us to do the integral of cosine x dx. Is what they're asking us to do. Because cosine x is the derivative. So to go back and find the original, we need to work backwards and find the antiderivative. And what is the integral or antiderivative of cosine x dx?
Negative sine x. Positive sine x. I don't know. You're confusing me.
I think it's positive.
I think it's positive. No.
Well, basically, go back and look. We've already done this example.
Yeah, it was the first one, right?
Uh-huh.
It's negative, so I was right. Right? No.
No,
It's the positive. Oh my gosh.
So we're doing the integral of cosine x, and the integral of cosine x up here is sine x.
Yeah. My brain said no.
Do we ever add imaginary numbers to derivatives? Stop.
No.
Because if we did, I know.
You drop out.
I know.
That's positive, right?
Yes.
Make sure you add the plus C.
No one said it.
Oh, it wasn't my
You got plus over as you
Okay.
I didn't say it back here, but I don't know.
Okay. Here's what I'm going to say. It may be implied, but I'm never going to write it if I don't hear it. Okay? So most of the time, if I don't write it, that means I didn't hear it. Now, whether someone said it or not may be a different story. I'm not going to say you didn't say it back there, Trevor, but if you said it at the same time as somebody else saying something else, you know. But, and the reason I do that is because I want you guys always thinking, you know, you guys always have to think it too. It's not, just because I can write it every time, doesn't mean you'll write it every time. And that's what's more important at this point.
What if we write it on the test for something that doesn't need it? Just, I'm probably going to do that now.
Plug in plus C. Julian plus C.
I'm just going to put it on every answer.
That could cost you, that could cause a problem.
C is 0.
So realize the plus C, but it could represent anything. But the plus C is only on antiderivatives or integrals.
Exactly. If it's a zero, that's